All right, today we're talking about slope, and to kind of help me with this, I have 2 points here, -4, 7, and 6, 0. I also graphed those. We'll get to that in a second. But the definition of slope is actually the change in our y values over the change in our x values. All right, so if we just look at that, kind of, I marked these out, x, y, x, y. We know how points work. But if we look at the change in the y's first, it says that that comes over the change in the x's. If I look at what happens with the change in the y's, well, from 7 to 0, it goes down 7. Right? So if I go down 7, I'm just going to put that over here. I'm going to say -7. All right? And then if I look at my change in my x's, from -4 to 6, I went up 10. All right, so a -7 over a +10. And that would be the slope of this, or of these 2 points. And if I look at it kind of graphically, does that make sense? So another way that maybe you've heard a slope before is rise over, do you know? Rise over run. Okay, so rise over run. Here, if I rise, that's like up or down. I think up or down. And I actually have to go down to get to my other point. And then I would run this way. So how much do I rise? I rise 7, because this is on our x-axis, right? Oops. And so I go down 7, and I run, you guessed it, 10. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I count the spaces in between those lines. So running, you always run to the right. So -7 over 10 is how we got that. So there's a formula that we can use based off of this. And if I kind of label these, if I call this my first point, I'm going to say x1, y1, because it's the first point, and the second point is going to get 2's, x2, y2. The slope formula that we can use is actually y2 minus y1, right? Our y's come first. This is a change in y's over the change in our x's, x2 minus x1. Okay? Because it's the change in those things. Change in math terms is the difference. Difference, of course, means subtraction. All right, so if I look at this here, the change in my y's, does it work? Change in y's, y2 minus y1, 0 minus 7. Yes, that's a -7. x2 minus x1, 6 minus a -4, which is like 6 plus 4. So that would also give me the 10. All right, when we talk about slope, there are 4 different types. Okay, the first type is a positive slope. And that looks like positive. That looks like it goes up from left to right as you view your graph. Okay, an example of that would be like 1/3. That's a positive number. -9, that would be like a negative slope. Okay, and of course, if you want to write that as an integer or as a fraction, you can. You can say -9 over 1. Remember, slope is always rise over run, so typically you see slopes written as fractions. That's going down from left to right as you read it. This is a pretty steep one, but it still is going down. Ones that are neither going up or down are like these next two. Okay, if it has a 0 slope, zero slope, if I spell it right, that means it's flat. Okay, think of like if you're out skiing, you go to the slopes. Well, at the bottom of the mountain, it's flat because there is no slope. It's just a flat line. And then undefined, this one is just a vertical line. Again, there's no kind of up or down like you see this. It's just a vertical up and down. All right, here's 2 different examples. We're going to actually find the slope. This first one is on a graph, and you can do this a couple different ways. You could pick out the points and do it like what we're going to do in example 2, or you could just think rise over run again. And so you always want to start, excuse me, you always want to start at your left point. And to me, it looks like it hits perfectly on my grid right here. And that's going to be my left point. The right point, it looks like it hits perfectly right there. Now, I will say it's not always going to be on your X or Y axis. This one happens to be that way, but sometimes you'll have these, these grid lines in between, and it'll hit perfectly on there somewhere with maybe another grid line. Maybe it hit like right there, for example. But anyway, this one does happen to be on the X and the Y axis. So to me, it looks like this one goes down 4. So it's going to be a -4 for the rise. And then it runs 1, 2, 3, 4, 5, 6. Okay, and of course we do not want to leave this unsimplified. We have to simplify it if possible. So -4 over 6 simplifies to be -2/3 for the slope of this line. Okay, which means if I go down 2 and over 3, yeah, it probably, if you had like graph paper, it probably would have also hit perfectly right there. So if you choose the 2 that are the most close together on where it hits the grids, you're going to have to, or you're going to get a slope that you probably don't have to simplify. All right, for the second one, here I give you two different points. And in this first one, it's -1, 2, and the second one is 3, -4. So I'm going to go back to that slope formula that we talked about earlier, which, if you remember, is y2 minus y1 over x2 minus x1. And if I label these, eventually you're going to get to a point where you don't have to label these anymore, but just xy, then my first one gets 1s, my second one's going to get 2s. X1, Y1, X2, Y2. And if I look at my Y2 value, that's a -4. -4 minus my Y1 is a 2. And then for the X's, my X2 is a 3. My X1 is a -1. So remember, it's minus the X1. So minus the -1 here. And I get -4 minus 2, which is -6. And then 3 minus -1s turns positive. So 3 plus 1 is 4. Those are pretty similar. Anyway, we can simplify this one more time to get -3/2. All right, so there you go. Those are the slopes of those two lines.